Well, there we go. Hi, everybody. My name is Mo. I work on partner engineering on the PTM team, primarily focused on gas. And today we'll be talking about gas, aka Google Automotive Services. Woohoo! So some of the topics that we're going to cover today is what is gas. We're going to spend only a little bit of time on that. We'll more be talking about the gas integration cycle and the gas partner requirements, the engagement during product development, building and integrating gas into your Android build, and testing your builds for gas, and finally launch readiness. So I wanted to talk a little bit about who this talk is for. If you're evaluating gas or working with OEMs on a new gas engagement, we wanted to provide this information as kind of a value add for you, so you kind of have an idea of how Google is engaged with the partners as we're working through some of these engagement. If you're working with some of our early partners, this is also relevant to you. And finally, if you're thinking about maybe integrating gas in the future, maybe this is not the right time, but something that down the road you want to be thinking about. This talk is meant to give you an idea of some of the things that we require and some of the architectural changes that you might want to think about as you move forward. So let's start with what is GAS. GAS stands for Google Automotive Services. As you all know, Android is free and open source. It's available to everybody. Google Automotive Services is proprietary. It sits on top of Android. And GAS is not a requirement. It's purely an optional kind of addition to Android. So GAS is a set of core services that Google provides that sit on top of Android that includes things like Play Store, Assistant, Maps, and there's a set of other services that are also available that are not listed here. But these are really the main ones that give some added value to an Android build. On Play Store, you get things like personalized app selections, an automaker channel where you're able to add OEM-specific applications and also promote applications that you want for your users. And then there's OEM app management and distribution. So Chris had talked a little bit about Play Auto Install. There's also the ability to kind of build in filtering so that you can filter apps specifically for like certain types of vehicles, things like that. We'll talk a little bit more about that later. Assistant, it's the same assistant that you're used to in your Google Homes, but in addition to that, it has the ability to do vehicle actions, so it can interact directly with the vehicle. So things like you want it to roll down the windows, you can tell Assistant to do that. And then if there's a whole set of vehicle actions that we'll talk about, but there's also custom vehicle actions. So if you want the ability to extend Assistant to do certain things on your vehicles, you're able to do that. There's also offline support for those scenarios where, for example, connectivity is not that great in a particular area. So there's a limited set of offline support, and there's deep integration with the vehicle. And then on Maps, there's two main components. There's navigation, and there's the vehicle map service, or what we call VMS, which is a data exchange meant to help the driver assistance scenarios. And then with each one of these, there's additional features and functionality. I'm only talking about them at a really high level. Like, for example, on navigation, we have an energy vehicle model that allows you to do some really cool things for your EV vehicles. This is all we're really going to talk about with respect to the product. Prior to any gas engagement, you'll need to work with Google's BD team. So if you're interested, please reach out to your BD representative. What we're going to start talking about now is more the integration and engagement model that we have. And when we talk about a gas engagement, there's three phases to the gas integration cycle. The first phase is the engagement phase. So in this phase, we, along with our partners, ensure that the hardware plans meet the specifications within the CDD and the gas partner requirements. We'll talk a little bit more about this kind of unique area of the integration cycle that's a little bit different than some of the other surfaces that we have, like, for example, on mobile. The rest of it is going to be very familiar and very similar to what we have in the mobile space. So, for example, we have integration and testing. And during this phase, we work with our partners to build these continuous testing scenarios, which work to help increase the quality of the builds. And then finally, launch readiness. So we work with our partners very closely on platform launch and shipping the actual product. So with that, I'm going to actually call my teammate, Harsha, on the stage, and he'll be talking about how to engage with Google.
Can just go back.
Green button.
Hi, everyone. So let me introduce myself. I'm Harsha. I'm part of the partner engineering team. I work mainly on assistant and on gas requirements. So my goal here today is to tell you how you could engage with Google when our business development team is ready to engage with you, and why we have requirements that we do, like why are they written this way, and what integration of gas involves, what you can do, what you can parallelize, and some things that you can think early to make the process more smooth for you. So first, to talk about engaging with Google about building a gas IVI. While developing Android Automotive and gas, one thing that we have realized that automotive software development is new for us at Android, and that it presents some unique challenges and interesting things for us about product development and the support. What I mean by this is, where we get this mainly is from the longevity of vehicles on the road because of the awesome cars that you build, and because of the long development time for the IVI. So this timeline is kind of our understanding of why this is different from other surfaces that Android has. So if we take today's date as a start, and let's say we have a hardware decision now, it takes about maybe 3 years on average to get your IVI build set up. And because cars are all about testing and having that stable build of software to ship, like maybe a year for that. From that point, cars are produced for some length of time. We found that the average might be about 3, and car sales start parallelly. And to get to the 90th percentile of sales, it might take about maybe 4 years. So what this means to us is, at 7 years point after the hardware decision has been made, a buyer is buying a brand new car, and they expect all the features to work, to have the best experience on it. So we want to get there. We want to get there with you, and that in a way influences some of the requirements that we have. Now, this is not even considering that the average life of the car is about 11.7 years from that point. So with today's date, with 12 years average time, the last car sold might want to be on the road till 2041, which is quite down the line. To give the difference between how auto and phones differ, think of a phone from 2011, which you would buy right now, and think of the user experience you have. I actually tried it, and Google Maps took about 14 seconds to start up, and then it crashed. So that is the baseline against which we are competing now, right? And users don't really want that in their brand new cars. So to accommodate this kind of a timeline and the expectations of users, we came up with this structured package on how you could engage with Google. And we call it the engagement package. It is a set of documents and tools with which to collaborate with Google. And I'll go over each one of them in short. There are the requirement checklists for gas and the Android, CDDs for Android. Then there is the Android Automotive System Compatibility, the AASC document. This is where you can give Google some details of your system design and architecture, thereby allowing us to comment on the architecture and tell you what we have learned from other systems and try to get to the checklists sooner. The VHAL implementation document is to plan out what properties you're going to expose to Android and to gas and to other applications. Some VHAL properties are required, some more are optional. It gives some space to see what is required there. And The next is the human machine interface interaction overview, and the UX experts at Google can talk to you, tell you what they have learned, and see that what you are building meets the driver distraction policies and our UX guidelines. It is a recursive process, so it is something where you collaborate with the UX teams. And knowing the production timelines is nice for us. If there is anything required, we can plan, and we can plan with you to know when the vehicles are shipping, when the IVI's code is going to be frozen. And the last one is with shipping the car itself, with internationalization and localization. And since this talk is about gas, I will go into a little more detail with the first topic here. Let me start off by saying that we still don't have requirements to give to you. We have not reached gas 1.0 phase. I think when we reach there, we will have high confidence on the requirements that we have, that they're going to be good. It doesn't really guarantee that the highway is going to be awesome for the entire life of the car, but there's a much better chance of it being there. Along with that, the requirements are not really meant to slow you down or thwart shipping of gas. It is our idea of what is required, and we have justifications on why it is required. It is not meant to slow you down at all. So 3 major categories here. There's the hardware requirements. Our guiding principle with hardware now is that we want to have better longevity support for longevity of the system operation and updates to the system. Along with having these must and should kind of requirements, we've added some guidelines. So that gives you some space to innovate and to be creative while designing your components. And some of these areas are the chipset selection. Last year, we had an update. I think we sent it out to all partners. And along with that, now there's connectivity architecture and the USB version. On the software side, in the previous talk, there was some talk about Treble. Treble is really nice to have for having updates for an extended period. Then we have product-wise requirements, with which you can get each of the gas apps running. It helps you to check them off individually and to do work in parallel, maybe. And security and content policy start to become important as the car stays on the road for a long time. And there are a few things that help with maintaining that as well. And I listed some examples here on how the requirements might affect your system design. The goal of this is to give you some topics to think ahead of time. When it comes to designing a gas system. And when you start engaging with Google, you have more information and you have a better idea of what you want to do. I'll go over a few of them. There's the first one, the system performance, something that we keep on talking about, phone from 2011 or car till 2035, things like that. How is the system performance going to be to support the platform and the application for long periods, with updates, new features being added, security patches being added to the system? Then if you want Google Assistant to work, how do you plug in your microphone and your noise cancellation so that the car can recognize the hot word like OK Google and the query accurately? And again, with the longevity, suppose you have a good upgrade path in the IVI for the user, like having an external storage or having a high data rate USB port available. Users could probably try to find something in that space, or you could give them some solutions if the head unit is slow in due course of time. The next one is, we're talking about gas as an application package, but I think the real value add comes from what you can give to the users to make it feel special. And there are a few custom things that you could do, but like having more VHAL properties or custom VHAL properties with which the user can do something or the car can do something special. For instance, with Google Assistant, there's something called custom actions, which can query a parameter and do more. I'll tell you more in the coming slides. Or you could have the instrument cluster integration with Google Maps, thereby showing the maps in the cluster display. There's also connectivity design, which has a few requirements and how the different modems are connected to the IVI. And the other things are related to security, and there's some use cases for DRM with some applications. Now, having said all of this, everything with gas does not fit into the must, should, and recommended kind of requirements that we keep writing. There are a lot of other things where you can use your creativity and try to, in startup language, delight your users. So that brings me to my next topic, integration. So for a few applications that I've selected, I will go over the mandatory things that you need to do to get it running, and the optional things you could do with which you can customize the user experience people have in your cars. Yeah. So this is our recipe to get gas working in the car. You start with AOSP, and then you add in some gas apps to it, and that gives you the bare bones gas IVR that runs with the basic features. Next, you add in all the required flags, properties, by which now the system has all the gas requirements met, and that is a compliant system at that point. And from there, you do the optional customizations from where you have a fully featured gas system. And at that point, you just build, run, and that's it. You have the gas system. Feels fairly easy, but and it is. That's the goal, that we try to make it as simple or as straightforward for you to do all of these. And we are going to write integration guides and post it so that many of these things become self-service kind of guides for you. So the first step is actually like I mentioned, you just take a correct version of Android Automotive OS, get your gas applications from your Google engineer, unzip them, add that one line to the build file, make and run on emulator. So this will give you the bare bones gas apps. And from here, you can evaluate gas, but the next part is to add all the mandatory things and do any optional things. Let's get to that. So these are the apps that I selected, and I can give you a brief overview of what they require for the current gas applications that we have. So identity. Before we get into the depths of this, one thing that I noticed from the talks in the last 2 days is many of them were covered in detail in the other talks. So all the things that are required here are part of the platform itself, and you enable these features or integrate them by which gas can work in a better manner. So there's no real changes to the gas apps itself. So for identity to work, you need to have a headless system user, and you need to configure the maximum number of users your system can have. Because you have a finite amount of storage space, having too many users can start affecting what a user can really do. So some plan there, that goes into the list of things to think ahead of time. And on the customization side, you can have a trusted device, and you can use the account manager to integrate your own ID into the car's account users. Next is assistant, my favorite part because I work on it day in and day out. And integrating it, you need to enable it with one line in the properties. And if you want to say things like tune to 104.9 FM, then there are a few APIs that you need to integrate. So assistant can call the radio, media, messaging kind of applications. And there are a few required VHAL properties that assistant needs so it can register the vehicle. On the optional side, now let's say you want to say open the windows or turn on the heater, or your kid is making a lot of noise in the back, so heat up the rear of the car to 100 degrees. So for those kind of things, there's the vehicle actions. It requires that you implement a few conditional properties, like for instance, HVAC and fuel. You could also say, okay, Google, fill up fuel in my car. We are not there yet, but maybe someday. But if you really have some use cases that are not part of a regular car, and you want to build it, then there's a custom actions platform. One example I like to give is to check if all the seat belts in your car are buckled up, or you have this amazing autonomous drive mode that has a different name. You could have a custom action with which the user can enable it with voice. Some other examples are with EVs, because they're everywhere. There are different properties that you can implement. The user can use these to get some data, or you can push data to the user with that. The next, I really like the previous slide. The next is maps. So to have maps working correctly, you need to have a content provider that can interface with the vehicle. There are a few VHAL properties to implement, and you need to implement the GNSS HAL. Now, which car here has an instrument cluster? What am I asking? Every car does, but do you want maps on it? So that's when the navigation state API comes in, and you can have the turn-by-turn guidance there. Does your car have a heads-up display? The same thing can apply there. So that is a customization you can do. And if you want maps to have a different UX feel, or to be opened in a particular manner for a particular application, you can broadcast map intents from your apps. And finally, electric vehicles are everywhere. Like at least in California, I think half of our parking lots are filled with electric vehicles nowadays. So Google has this energy model for the vehicles, and based on the parameters and the characteristics of your car, you can tune this model. This unlocks a few cool features like what percentage of battery do I have when I reach my destination, or which route is most optimal for me to get there, or where do I really need to charge the car to in fact get to my destination with the electric car, which I think is a pretty important thing given you can't just refuel anywhere. VMS has a few VHAL properties that you need to implement. You might notice that some of these are actually repeated from the previous slide. Gas applications are built together and they're tightly integrated. And this is one place where it shows up that they in fact do reuse a lot of the things and are tightly integrated. And in case of VMS, you might need to do any conversion between the VMS and ECU data formats. On the optional side, if you have any existing ADAS cases or you want to add new ones, those are something that you might want to think about ahead of time. And that's a lot of integrations and customizations, especially on the integration side, right? Like we're done with only 4 applications so far. But bam, there's Setup Wizard, works out of the box. And so Setup Wizard is where you do the first time out of the box flow for the user. On the optional side, like let's say you want to add your own screens or change the flow of the screens, or have your own user login to be integrated into the wizard. It is all possible. You can also change the look and feel to feel more like how you want your UX to be. Play Store is very similar in that it works out of the box. You just install it and it works. There are a few things that you can do is to have your own OEM channel. Mo was talking about it earlier. This is where you can directly talk to your users with apps that you develop. And you can reduce the size of the factory image by using Play Auto installs or set up filtering for the apps. So this is all to do with the integration of gas, a lot of development, and testing goes well with development. So Mo is going to tell you more about it.
Thanks, Harsha. Okay, so we talked a lot about integration. I now want to kind of flip to testing and what it takes to have a quality build that has gas on it. As you guys know, there's some additional tests that are required for gas. A lot of these are going to sound familiar. One of them is, or a couple of them actually are be quite new, but it's going to be very similar to what you find in other surfaces. Before we talk about the tests themselves, let's talk a little bit about the process for doing tests and submitting them to Google. So the gas testing process is meant to help partners ensure that their builds meet high quality standards and to provide better reliability for your users. It's modeled after the testing process in mobile. So it's very similar. If you're familiar with that, you'll be very familiar with it. Essentially, what we do is we have partners execute gas tests. You can submit build and test results to APFE, the Android Partner front end, and you can submit them incrementally. So they don't all have to pass before you submit them. It's totally up to you guys, though. It does provide a very good reference if there's like a failure and Google has to do some investigation. It does provide a very good point of reference if we have the test results there. But it's up to you. So you can submit results incrementally. Once all the tests pass, essentially the partner then requests approval. And one of the test suites that's a little bit different is the build test suite. We'll talk a little bit more about it later. But that test suite's actually run on the Google side. So that test suite basically checks to make sure that the build doesn't have any malware based on signatures that we know and are aware about. And if everything passes there, then the build is approved in AppFi, and you're at launch readiness. Some of the test suites that are required for GAS approval. So GAS is incremental to Android approval. So first you have to pass the CDD and CTS. But at the heart of the process is a set of test suites And we built them kind of with the intention that they're run continuously throughout development and not something that you just run to get approved. So something that can really help your developers and ensure that there's when there is a regression, you catch it early. Many of the test frameworks are the same as the mobile test frameworks. We talked a little bit about VTS, which is the vendor test suite. It tests for trouble compliance. BTS is the build test suite, and that tests for malware. STS was talked about earlier as well. That's the security test suite, and it ensures that patches are at the right levels in your build. The ones that are different are ATS. ATS stands for the automotive test suite. If you're familiar with mobile, there's something called GTS on mobile. So this is the automotive kind of version of that. We do use tests from GTS. So we do port some of those tests over. But then there's additional automotive specific tests that will get run through ATS. And then there's ART. ART stands for the Assistant Readiness Test. And that tests the speech and audio capabilities of your builds. So invariably, whenever there's you have a test, there will be failures. That's just something that we expect. And I wanted to talk a little bit about how you work with Google when there are test failures. Obviously, so if you're familiar with the CDD process and with CTS, you're familiar that waivers are only issued if it's a test issue. And the CTS waiver guide specifically says that you submit a patch as kind of proof that it's a test issue. For ATS, it's not that easy. ATS is not part of AOSP. And so, but we do follow a very similar model. So waivers are only granted if it's a test issue. But we ask that you submit a bug, and then we help to investigate and make sure that it is an actual test issue. And it's, it happens all the time. It's totally legitimate that it could be a test issue. What we do ask is that you collate as much detailed information as possible about the test failure. You submit the test through review through Issue Tracker, so you'll have access to, we call it internally as Buganizer. We call it externally as Issue Tracker. And then ensure that the information is technically accurate. And then our team will work with the cross-functional team. So we'll reach out to the engineering teams if it's something that we don't know, and make sure that it is an actual test issue, and then issue a waiver if we find that the test is failing legitimately. Finally, something I want to say is, start your testing early. This is a particularly old study that was done on the cost of defects throughout the development lifecycle. However, I think it's actually really valuable. I don't think I have to tell anyone in the room how expensive defects are once they get to production and post-production. And so the goal of testing is really to catch problems as early as possible. So testing early and setting up your test infrastructures as early as possible helps to reduce the odds of finding issues later. It clearly sets the expectations with your development team as to what you need to do when there's a regression. For example, even if you're failing some tests, and let's say you're passing 80% of the tests today, and tomorrow you're at 75%, you know that there's a regression. So it's very valuable information. You don't have to be at 100%. It's extremely important to set these things up early and set the expectations with the development teams. It creates a clear implementation path. And a lot of times with my teams, one of the things I tell people is, bugs are non-value add. And you want your teams to be working on value-added stuff, which means features. You don't want people to be chasing bugs all the time. So setting up these test infrastructures helps your teams actually spend more time on features and less time chasing bugs. And we found that that's particularly important as we work through some of these gas engagements. And overall, it builds for a smoother partnership. If early on you set up your test infrastructures and you get all the trade-fed test suites running, things like VTS and ATS and STS, and these things are running consistently, we find that it actually makes for a very smooth partnership. It helps to actually build knowledge both at our partners and internally, and it helps us to be able to communicate better. So it's super important. Okay, Final thing is one last short slide is launch readiness. So as we said, basically, once the build is approved in APFE, that means that that build is ready to ship. And just the one reminder, in the earlier slide, we talked about the different phases, and it was a kind of a circle. So this is more of a process. Once you have a build out there that's approved, if there are security updates or if there are changes to the build which change the build fingerprint, those are going to require reapproval. However, having said that, those are usually incremental changes. You're not seeing these like massive changes. So it's typically we'll look at there'll be some differences and potentially some failures that we'll have to look at, but it's not going to be like, let's just do this all over again. Okay, just a quick recap on all the things that we talked about. So we talked about what is GAS briefly. We talked about the engagement model, and we talked about why this engagement model and the differences in the auto industry, how they drive kind of the changes in the way that we look at requirements. We talked about integrating GAS and what's the process of that and what things you guys have to think about when it comes to integrating GAS. And we talked about testing GAS and build approval. And hopefully with all those things, they've given you guys a glimpse as to how this process works so that maybe as you think about GAS, you have a better understanding of the process. And with that, I just want to thank everybody for listening to Harsh and I yap for a little bit about GAS, and hope you guys enjoy the rest of your day. Thank you.